So our first approach to define flex spaces is to say that it's the size along the main axis. Now, I hope by now you understand that we are speaking about the main axis of the containing element, actually, because it's always the containing element that is kind of defining how the its items can actually stretch and can actually behave, because it actually defines how much space they have available. Um, Now, one way to put this in other words that makes it maybe a bit even a bit more useful is to say that it is the size on the main axis that the element actually wants. Now, what I mean by that is when we change the flex basis of this red box to 600 pixels, and when we now duplicate this element, what you can see is we have two elements with a basis of 600, but their real size isn't 600 anymore, right? This is 600. Those are real 600 pixels. When we duplicate it, both of those elements are smaller than 600. So they still have 600 set as their basis, but they cannot reach this basis or this size because there's just not enough space in the container. So in that sense, it's useful to think about the basis as the ideal size kind of along the main axis. So the size that the elements want to take. Now, technically, how this works, and now we get into this thing, how those three properties always play together. The reason that they kind of take up exactly the space that they have in the container is actually because the shrink property per default is set to 1. And this allows them to say, okay, we have a basis of 600. Let's see how much space the container gives us, and let's see, can we reach our ideal size? If we are allowed to shrink, we cannot reach our ideal size. We will just use that much space that we have. And when we both have the same basis and both have the same shrink set, when shrink is set to 1 in both cases, they shrink kind of in the same way, and that's why they have the same size here. Now, look what happens when I take this element and I remove the shrink, or I set it to 0, which actually means you are not allowed to shrink. You have to be what your basis tells you. Now you can see the element ignores the other element kind of and says, okay, I'm taking as much space as my basis is telling me. And now the interesting thing is what happens when this element also is not allowed to shrink. Now the elements leave their container. And you would consider this as a kind of broken layout most of the times, because the moment when they leave their container, probably there was a reason why this container had as much space as it had, and probably there might be some other element here, and now this element would just ignore that and would overlap them and say, okay, you are not allowing me to shrink, so I have my basis, I'm not allowed to shrink. What am I supposed to do? I have to kind of adhere to my rule and take up as much space as my basis is telling me. And that's why those elements by default have a shrink property of 1, which means that they will nicely use the space that they have because they are allowed to shrink.